This time we have to write the equation of a line with the slope negative 2/5 and passes through the point negative 7, 3. The thing that makes this example worth doing is that the slope is a fraction. Okay? That's what makes this one just a little bit harder than the previous example I did on writing the equation of a line. So let's start drawing it, and we'll start to draw the line by plotting the point negative 7, 3. So over to negative 7 and up to 3. So there's negative 7, up to 3 is here. Okay, so there's negative 7, 3. Now the slope is negative 2/5. Okay, now remember, slope is rise over run. Okay. Now, so that means our rise is negative 2, which means down 2. So, okay, so from our first point, come down 2 spaces, or down two squares, or 2 rectangles in this case, come down 2, 1, 2, and then move 5 to the right. Okay, so negative 2 over 5. The negative 2 means down 2, and then move 5 to the right. So 1, 2, 3, 4, 5. So there's where our second point is going to be. It's going to be at point negative 2, 1. Okay, so we can take our line tool and we can draw a line that goes through those 2 points. Hopefully we can manage to do that reasonably. Let's say we take a red line. Okay, and the line tool, so let's try and do this. Should start on either one of those points. Let's see if we can do it as accurately as possible. That's pretty close without spending too much time on this. And extend it on through that other point, which is pretty close to being there. Okay, and we'll also take this side and drag it on out to the end. And that's pretty much the line that we want to draw. Okay, so that's the line that we're going to draw. But what we want to do next is we want to write the equation of that line. So if you've watched the previous example, you'll know that I prefer to use y minus y1 equals m on x minus x1 as my formula for finding the equation of the line. You can always use y equals mx plus b as well. I'm not opposed to you using that. I just happen to prefer this one. So our point is negative 7, 3. That's our point. So that's x1, y1. And we already know the slope is negative 2/5. And that's our m. Okay? So we're going to start filling those different bits and pieces in. So we're going to have y minus y1 is 3 equals m, which is negative 2/5 on x minus x1. Now x1 is minus 7, so it's going to be x minus minus 7. Minus minus is plus, so x plus 7. Okay, now here's what I prefer to do when the slope is a fraction. Some people multiply and distribute the negative 2/5, and you can do that, but I prefer not to work with fractions. To avoid the fraction, what I'll do is I'll look at what is on the denominator here. It's 5. And then everything that isn't in parentheses, I'm going to multiply by 5. Okay, so this fraction isn't in parentheses. I'm going to multiply that by 5. This y, I'm going to multiply that by 5. And the negative 3, I'm going to multiply by 5. So I multiply everything that isn't in parentheses by the denominator of the fraction, which is 5. So I'll multiply everything that's not in parentheses by 5. Okay, so let's follow that through. And that's going to give me 5 times y is 5y. Negative 3 by 5 is negative 15. Now when we multiply the negative 2/5 by 5, the advantage here is when you multiply a fraction, negative 2/5, by its own denominator, 5, then the bottom of the fraction goes away and you're just left with the numerator, in this case negative 2. So if you multiply any fraction by its own bottom, you're just left with the numerator, so negative 2. And then the x plus 7 doesn't get affected at all because it was in parentheses. Okay, from here on it's pretty simple. I'm just going to distribute the negative 2 here. Expand this side, so we'll have 5y minus 15 is equal to negative 2x. Negative 2 by 7 is negative 14. We want to get the y on its own. So remember, we're going to bring this negative 15 across. Remember, slope-intercept form, which is the way we want to write our equation usually, means y is on its own. So we have 5y equals minus 2x, minus 14. If you bring the minus 15 over, it becomes plus 15. So tidy up these numbers. 5y equals negative 2x minus 14 plus 15 is going to be plus 1. And then because you want y on its own, you'll divide by 5. Divide by whatever is in front of y. Divide by whatever is in front of y. So you have 5y divided by y equals negative 2/5 x plus 1 over 5. Now, we're nearly there. The 5's will cancel there, and you're left with y is equal to negative 2/5 x plus 1/5. Okay? Y is equal to negative 2/5 x plus 1/5. And if we go back to our line here, the equation of this line, y is equal to negative 2/5 x plus 1/5. Sorry, that's a little bit difficult to read. We already know the slope is negative 2/5. The other thing that's interesting about this is this 1/5. Okay, this 1/5 at the end here. This part. This part. What that refers to is the y-intercept. In other words, where it crosses the y-axis. Okay, so you can see that that's 0, and that's 1, and this is exactly 1/5 of the way up. Okay, so you know this from before, but remember, the plus b part, y equals mx plus b. This plus b part that you're left with, that tells you how high up the y-axis the line goes through it. Okay, so it goes through it at a height of 1/5. Okay, it's a little bit longer than the last one because of the fraction. What I want you to do rather, to get some practice, is to try doing this problem, very similar problem. Try finding the equation of a line that has a slope of negative, let's say negative 3/4, and that contains the point, let's make it 3, 7. Okay, so try to find the slope. Try to find the equation of a line that has slope negative 3/4 and contains the point 3, 7. Okay, should be exactly the same as what we've just done. So if you get stuck, go back and look at this example again.